So you've been asked to sketch the particular solution this time to the differential equation using the slope field in question 6, and here's the slope field in question 6. So if I see 1 here, and it's hard to see, but this is 1 up here, here's the dot that represents that first initial condition. And so I'm going to then follow those slopes to the right. We can see we very quickly climb. And then going to the left, I bend down, but then I hit a 0 slope. How do I know it's 0? Because if all of these from each direction are coming in, the only way that they're going to ever meet is if I'm 0 halfway between them. So that's my that's my particular solution through the graph. And now as I look when x goes to infinity, my graph goes also to infinity. So this first limit would be infinity. As I go towards negative infinity, well, you can see we are approaching the x-axis, which would have a limit of 0. And now the last question, which of the following could represent f of x? Well, I'm not exactly sure what this is, but I know it can't be x squared. And I know it can't be ln of x, because ln of x is generally going to look like that. So I can rule out C. Well, this does look exponential in nature. Notice it has an asymptote of y equals 0, and it seems to climb exponentially. So far, I'm looking at D and B because they're both exponential. This last one is rational, and so I'm going to have asymptotes when my denominator is 0. So I definitely don't see any asymptotes at -1 and 1. So I can rule out this one. So all I'm really looking at now, process of elimination, do we want y equals e to the 2/3 x minus 1 cubed, or y equals negative e to the negative x to the 4th minus 3? And here's where we can decide. This is a negative exponential, so instead of going up, increasing, ours is going to increase exponentially down. So it can't be B, but it could be D, and it must be D.